Hey everyone, in this video I'm going to quickly go over how to configure a virtual link in OSPF. Now the problem that we run into with OSPF areas is that all OSPF areas have to be connected to the backbone area, or area 0. And in this topology, I have this link between 6 and 7 are in area 67. These links here are going to be in area 4, 5, 6. And then everything else is going to be in area 0. Okay, so what's the problem? Well, with OSPF, it can only confirm that a path is loop free if it's within the area. That's because OSPF only runs the shortest path algorithm on intra area routes. Once we start going to inter area, OSPF loses visibility and then can no longer guarantee a loop free path. So, this means that all Type 3 LSAs must pass into or out of Area 0. Therefore, a router like 6, even though it's a border between two routers, this is not going to be considered an area border router. And we can confirm that by going to 7, show IP OSPF border routers, and we can see we don't have any border routers, even though I'm a neighbor with 6, and if you look at 6, I have a full database of the topology. So how do we fix this? Well, the correct answer would be to redesign the network, because virtual links are a temporary solution. But what we can do is we can create a virtual link here. And specifically how this is going to work is there are a couple caveats I need to go over, and then we'll just go ahead into the configuration. The first one is that the virtual link, both endpoints must be on routers that share a common area. So if R6 was in area 456 and R4 was in area 17, they wouldn't be able to form a virtual link. The other thing is that they can't form through a stub area. This is because a stub area is a non-transit area. So if 456 was configured as stub, the virtual link would not form. The last thing I wanted to point out is, I didn't mean to make that mark, but the last thing I wanted to point out was that the virtual links do not need to be directly connected. In this case, I'm going to create a directly connected one between 4 and 6. But if these routers were in 456 as well, you theoretically, well, not theoretically, you could configure a virtual link multiple hops away. So what we're going to do is we're going to configure the virtual link between 4 and 6, and we'll see what effect it had on R7. So let's go ahead, and actually first on R7, I'll just show you the database as well. So you can see all we have is the stuff that's inside Area 67. We don't have anything else. So let's go to R6. And let's do show IP OSPF neighbors, because we're going to need to know the router ID of R4. Conf router OSPF. And now we gotta have to configure the area for the virtual link. You might think the area is 67, but it's not. The area is 456, because this is the transit area that the virtual link is going to traverse. So now that we have the virtual link, you'll notice here we have to configure the ID associated with the virtual link neighbor. It says IP address here. I don't like that it does that, but in OSPF, your router ID looks like an IP address anyway. So another good reason to hard code your router IDs, instead of just letting the regular election work with the highest loopback or whatever. Hard code your router ID for, so you can do situations like this. So we're going to do 4.4.4.4. And then we're going to go to router 4. 56 virtual link, and our neighbor is all 6s. And now what we can do is show IP OSPF virtual links, and we can see that our virtual link is up. We could see router 444, see it has a cost of 1, and it's a point-to-point. And then we could also see the intervals, the adjacency state is full. So if I went to show IP OSPF neighbors, we could see we now have 2 neighbor relationships with 4. We have this one over the gig 146 link, and now we have one over an OSPF VL1 link. And this is also in the show IP OSPF interface brief command. We could see we now have interface VL1 with a cost of 1, and it's a point-to-point link. So I just want to show you a couple of show commands where you can verify your virtual link. Now let's head over to R7. Let's do the show IP OSPF database again. And now we can see we are starting to get, well, we're not starting, we have all of our type 3 LSAs. And if we do a show IP OSPF border routers again, we could see that router 6 now considers itself to be an ABR. So let's ping all the way across the network, and we have a success. So this is how to use virtual routers, virtual links in OSPF. Again, this is a temporary solution in a production environment. This would be a temporary solution to a topology problem. In actuality, you would want to redesign this network. But for lab purposes, this is something that you're going to need to learn how to configure. So thanks for watching, and we'll see you on the next one.